Hey guys, welcome. We recently switched our platformer controller from a dynamic rigid body controller to a kinematic raycast controller. And then we added support for slopes. And when you're using nothing more than a cube for your character, it's pretty easy to write everything off as working perfectly already. But raycast controllers can be notoriously difficult to bring to the next level, which is to get them stable enough to rely on for things like animations. If we go over this little hump and even for a single frame we lose our isGrounded reference, then our isFalling animation is going to start playing. And it's not the most jarring thing in the world with my controller because this guy's animations are kind of subtle, but if you have a very expressive character, then this becomes extremely jarring and it ruins the immersion. But more than that, it makes it hard to actually trust the state of whether we're grounded or not, which is no good. So we're not going to be doing any big flashy updates or new mechanics in this video. Before we move on to the stuff in the future that I'm really excited about, we need to tighten up this system to make it solid so that we can 100% rely on it. We're still sticking with our raycast system, we're just going to make it a bit smarter and at the same time make it easier to read and understand. The changes in this video are really going to take this to the next level. If you want to test out this controller for yourself before committing to following this entire series, I've uploaded a little demo on itch.io, link is in the description, so go ahead and grab a controller and test it out if you like. And as a special thank you to my patrons, this project is available in a state machine pattern over there, so if you want to grab that and support the channel at the same time, then head on over to Patreon. And a big thank you to all of my current patrons. So let's do it. Ready? Let's go. So before we move into any big refactors, I have a few small improvements I'd like to add in that's going to eliminate some edge case bugs after the last video. And to make that a little bit easier, I want to go into our player movement script, right down to our helper methods, and make isSlidableSlope public. And we're also going to add an isWalkableSlope method. And an isWallSlidable method. This is going to make it so we don't have to keep on writing the same checks over and over. Okay, now in our move controller, we're going to go down to our ResolveHorizontalMovement method. And right here, we're going to add a check to see if it's hitting the lower half of our body. And make sure we only call climb slope if that is the case. And let's also make sure it actually has an angle as well. Before, if ray 0 happened to miss, but the next ray up hit, then we would just stop. The change we just made could allow for more unique or spiky terrain. It's just kind of a nice safety net. Now, down in slide down max slope, we should be setting is descending slope here because we are descending a slope even if it's a slidable slope. In climb slope, we're going to add another float parameter and pass in our original velocity. We save that up here right at the start, and this is safer because we were just using our velocity, which can potentially change with every single ray iteration. By grabbing it before, it's going to be more consistent. This keeps us from stopping if we were to start climbing a slope from, say, ray 1 if ray 0 happened to miss. And finally, I realized that some of you might want the option to be able to wall slide or wall jump, whether you are facing the wall or not, and it's pretty easy to add. In our player movement stats, let's add that as an option under wall slide. And now at the top of apply slope stick, we want to check if the wall is wall slidable. Are we facing the wall? And should we wall slide based on our facing direction and the option we select in our scriptable object? If we should wall slide, we'll return because our wall slide method will handle that for us. Otherwise, we'll call the slide method because to me that makes the most sense if you don't want to wall slide but your back is touching a wall or a slope that is within our wall slide threshold. Now this isn't going to work yet because right now our raycasts don't check on both sides of us, but we will be changing that really soon. Okay, let's go to ResolveVertical Instead of just changing our velocity.y directly like this, we're going to call that calculation. And if it's greater than 0, but also less than our collision padding, then we will make it 0. And now above all that, we calculate the distance to the floor. And if we're sliding, and we do have some distance to the floor and the slope isn't a wall, then we're slightly inside the geometry and we need to calculate a push out amount and apply that to our X velocity. Before, our vertical velocity, if it detected that we were in the geometry, it would just push us up, but not out. This fixes that. All right, that is it for all of the little tweaks and improvements. So right now, our ResolveHorizontalMovement and ResolveVertical methods, they're trying to do too much at once. They're keeping us out of the geometry and they're setting all of our collision states. So they're doing the sensing and the moving of the player. And the sensing can be really problematic when you're constantly resizing the length of the ray throughout the loop and just doing everything that we're doing here. It's too much. Not only that, but we're also calling move at the end of our fixed update in our player movement. And with this current architecture, we have to. But that means move gets called at the end of the frame. Inside move, all of our collision states get updated, which means all these methods here are operating a frame too late. And this can get really confusing when you're in the weeds trying to debug stuff. And it makes it very confusing later on if you're trying to add things like moving platforms. So we are going to strip the sensing part of these methods out completely and call that at the start of fixed update. So our resolve movement methods, their only job will be to keep us out of the geometry, and our sense methods, their only job will be to update our collision states, and it will not be delayed anymore. So after this update, we're going to get the best of both worlds. Again, I know it's not the most exciting update, but it is vital to making this controller usable for production. So we are going to have some collision info that we need for our resolve movement methods and all the rest, which is going to be for our sense methods. So to keep from getting confused between the two, we're going to add a struct where we'll keep all of our sense data. Now we can delete all of these. We can move these into the struct. And this too. We can delete this. And this. We can move these into the struct. And we'll add all of these. And yes, we do still need the slope angle and slope normal to be in the struct and outside of the struct because the sense and the resolve movement methods both require references to it. And since the timing between the two are going to be different, we're going to keep both. We're also going to build a reset function right into the struct, which is just going to reset everything every frame. Okay, now we'll create a public property for the struct, as well as a private variable. IsSliding is now going to be based on the slope angle in the struct. Our sensors are going to have a whole separate set of rays that they cast, so we're going to add our distance up here. And we're also going to create a grace duration for being grounded after we've been climbing to help with stability. So here's what we need for that. And now finally, here's the new method we're going to be calling at the start of every fixed update. Okay, so let's at least create the horizontal probes, ceiling probes, and ground probes methods to avoid at least a couple of errors in the script. We do not need this in move anymore. That was added to our pull sensors, and this was moved over there as well. And let's clean up the reset collision states methods since most of these don't even exist anymore. In check ceiling boxcast, we want to update this reference to grab it from our struct. In resolve vertical movement, we can remove these. We don't need the horizontal projection in our ceiling checks anymore. Now inside the if hit block, we're going to grab the angle. And just to save a little bit of time, a lot of this is going to be reused. So let's cut all of this, starting with current ceiling angle all the way down to our debug visualizations. And we're going to paste that into our ceiling probes, but in order for that to make sense, we might as well start that method so it goes in the right place. So we only do anything with this if our Y movement is not negative. We're going to grab our ray length and set up bools for our corners. And we're going to use the same number of vertical rays and loop through those. Our ray origin and raycast will be set up the same, nothing different here. And then if we hit something, we want to grab the angle of what we hit relative to down. So 0 would be a flat ceiling and 90 would be a wall. And if our raw hit angle is super close to a wall, I'm just going to hard code 85 degrees here. Then we'll skip this ray iteration and move on to the next. We want to check if this is an edge ray, meaning the first ray or the last ray. And if it is, and our hit distance is 0, then we're flush with the ceiling or even potentially slightly inside of it, and our angle is 0. And if that's the case, then we'll skip this ray iteration. Okay, now we can finally paste what we cut. And at the very bottom, we can say, if we hit both corners, then we'll set is hitting both corners to true. We will need to change a few references here because we're setting these in the struct now. So I'll just update all those real quick. And we're not going to be changing ray length or the velocity here either. Now back to our ResolveVertical inside the ceiling check, we're going to make a few improvements here to how we are doing this. So if our hit distance was 0, let's create a shift direction vector 2. If it's the left corner, then we're going to shift to the right. If it's the last ray, then we're going to shift to the left. And then if we have a shift direction, we're going to cast another ray up from our shifted position again, just in case our corner ray happens to be inside a wall, because that does happen sometimes. And if we hit something with that ray, then we'll grab the angle. And if we hit nothing, then this proves we were just clipping our ray into a wall. So we'll set the angle to a wall angle. Now, if that angle is over 85 degrees, so a wall basically, we will skip this ray. If we made it past that and our hit distance is 0, then we need to halt our Y velocity immediately. Otherwise, we treat it like normal. We set the velocity.y to hit.distance minus collision padding and change our ray length to be that hit distance. Now, there really isn't anything that we can reuse for ground probes from our ground check region, so we might as well just continue with ResolveVertical and finish this method up. So we can remove this check. We'll add a found walkable ground check. We can delete everything inside if hit. We're going to grab the angle. Check if that angle is walkable. And check if we are sinking. And if we're not sinking and the slope we're on is not walkable, we're grounded, and our current saved slope angle is less than our max angle, if all of that is the case, then we're going to skip this ray. We definitely do not want to skip if we are sinking into the ground. If we haven't recorded found ground as true yet, then record the hit distance, the ground hit, and set found ground to true, and set our found walkable ground to equal our is hit walkable. Otherwise, if we haven't found walkable ground yet, but this hit is walkable, then take it by setting everything. If both are walkable or unwalkable, as long as they equal each other, then we're going to take the closest one. And we can delete this else. And same with these. And this section here should be totally fine as is. And we should delete the slope normal visualization here as well, because we're going to rewrite that in the ground probes later. And let's just quickly go through what we pasted and make sure that we're using the struct version of variables, and also delete anything that is now irrelevant or doesn't exist anymore. And all of this can now be deleted. Okay, so now moving on to resolve horizontal movement. And this one is pretty minimal for changes. We can get rid of this and these. Inside our if is sliding check, we'll check if it's a wall, and if it's not a wall, then we'll skip this ray. Delete this and these. And we'll need to redo the debug visualizations inside horizontal probes, so we can delete that as well. We might as well finish our cleanup at this point. So in our climb slope method, let's get rid of this. And in descend slope, we're going to get rid of our if is not sliding guard. And after we find our slope angle, if it's greater than the minimum angle for our wall slide, let's return, because that should trigger a wall slide, not a stick. In apply slope stick, we can get rid of this. And in slide down max slope, we'll delete out everything that no longer exists. And to save us a lot of time from having to refactor a whole bunch of things in our player movement script, because they all just call these helper methods, let's just change what these helper methods are looking at. So we can just grab the appropriate variables from our struct. The only thing that still is going to need at least some correcting is the isTouchingWall, because we won't be passing in a bool anymore since we're going to allow this check to happen from either side. All right, let's do ground probes now. We are going to add quite a few safety features in here to ensure that we return isGrounded in every possible scenario that it should. So all of this at the start probably looks familiar by now. We're going to add a horizontal projection to the ray origin if we're not against a wall and we're not against a steep slope. We're going to loop through our number of rays and actually cast the rays. And let's go ahead and add our debug visualizations for our ground probes here at the beginning. Now, if our ray hits something, we grab the angle and check if it's walkable. If we haven't set found ground yet, then grab the hit distance, set the ground hit, set our bool, and set our found walkable ground bool as well. If we've already set our found ground, then let's check if we did not find walkable ground and check if this hit is walkable ground. And if so, grab the hit distance, set our ground hit, and set our found walkable ground to true. And we'll also check if found walkable ground and is hit walkable are both either true or both false. And our hit distance is the smallest hit distance that we have found yet. If so, set that as our new smallest hit distance and use that as the ground hit. And this is going to be new. So after our hit check, we're going to say else if we're climbing a slope or descending a slope. If either of those are true, then we're just going to automatically set isGrounded to true. And we're going to update our slope angle and slope normal in the struct to be equal to the non-struct version, since we're going off of that information here. And if there's even a slight angle, we'll also set our isOnSlope to true. And after that point, we'll return, because there's no point in continuing since we're manually setting isGrounded there. Now, if we found ground, we're going to grab our slope angle. Check if the angle is wall slidable. And check if we're facing the wall. and then ask, should we wall slide here? Which either would be based on, yes, we are facing the wall, or we set the option to be able to wall slide facing away from the wall. If it's wall slidable and we should wall slide, then here we'll actually set is against wall to true and set our wall angle and wall direction as well. If that's not true, then it's normal ground, and we'll set our is grounded to true and set our slope angle, slope normal, and our is on slope if there is a slope. Now, if we did not find ground, we're going to add a couple of safety checks. First off, I noticed in testing that one of the most common scenarios for a fail was right after we transitioned from climbing to descending. So let's check if we were climbing last frame. Set up a new safety distance, safety ground bool, and raycast hit 2D. We're going to do another set of raycasts here, but send them down quite a bit further, 5 times in this case, to be able to account for really steep slopes if necessary. And if we hit anything, then set everything that we just set up. And if we found ground from that, grab the angle and make sure that it's not wall slidable. And from here, we're going to set our last safety ground time, our last hit, and set our is grounded to true, as well as our slope angle, slope normal, and is on slope. Now we're going to do a little safety grace time check. So if our current time minus our last ground fixed time, which we just set up above, is less than or equal to our grace duration, then again, find the angle. Make sure it's not wall slidable. Set our bool to true, and set our is grounded, our slope angle, and our slope normal, and our is on slope. And finally, if we did not find ground and we haven't used a safety recently, then we're not grounded and we're not on a slope. And right at the end here, let's make sure that we're drawing our slope normals if we selected that option. Okay, I promised that was the longest one. So let's go ahead and do the horizontal probes, which is much shorter. So we set our ray length like normal. Loop through our number of horizontal rays. And this time we're going to specifically check left first. So we'll cast those rays. And we can draw them if we turned that option on. And we can set a found wall option here, which we'll use right at the end. If we hit something on the left, grab the angle. Check if it's a slidable slope, and if it is, set that we are against a steep slope. Check if it's wall slidable, and if it is, set our is against wall to true, set our wall direction, and our wall angle, and we can say found wall is true. Now we're going to do the same thing, but on the right side. So set up the ray origin, and cast the ray. We can draw that if we have the options selected. And if we hit, this can all be the same as from above, so we can copy and paste that in. Just make sure that we replace hit left with hit right. And then finally, if we found a wall, we can break out of the loop. We don't need to continue at that point. And before we continue, I paused recording here just to check if I made any errors. And we do need to go back to ground probes. And in our ray origin safety, this should be vertical ray space, not vertical probe distance. Also, in our descend slope, when calculating our max expected vertical drop, this should technically now be changed to minimum angle for wall slide. And not that it really matters, but I'll correct this spelling mistake in our ResolveVertical Okay, that should be everything inside of this script. Now let's go back into our player movement script to clean it up. So let's go to handle head bump slide. We should actually be checking to make sure that we're not against a wall here. And then we'll clean up any remaining errors in this method. Let's go to land check. And we're actually going to add in is head sliding check here, because in certain edge cases, this can be true. And I want to improve this down at the bottom just a little bit. So we are going to say, are we stable? Meaning, is our slope angle under our max slope angle? And are we against a wall? And we'll reset our air jumps if we let our player reset air jumps on a max slope land, or if we're stable, or if we're wedged. Okay, next, let's go to jump checks. And right here, we're going to add, or if we're sliding, or if we're against a steep slope as well. And let's clean up any remaining errors here as well. Small change. In initiate jump, we want to ensure that we set jump pressed to false here. As soon as we use it, we want to consume it. And we'll do the same inside initiate wall jumps as well. We might as well add dash pressed as false into our initiate dash as well, even though we only have one ability assigned to it in this project. It's still good practice though. Now inside our should apply post wall jump buffer, let's wrap the line where we set our last wall direction in to make sure that our wall direction is not 0 first. We'll clean up any errors here as well. And one more minor change to make the controller feel a little more forgiving. Let's go down to count timers, and we're going to remove our is slidable slope checks from handle coyote timer and handle dash on ground timer. It felt a little too restricted before, like if your foot was touching a slidable slope, those timers wouldn't count correctly. And now we're just going to clean up any more errors that are left. If you're using Visual Studio, you can see errors as little red dots in the scroll bar here. So we need to clean up dash. And wall jump. And wall jump check. And wall slide. And jump. And velocity reset, and we can just get rid of this is on slidable slope check here. And it looks like I missed one right at the bottom of handle head bump slide. And finally, we go up to fixed update, and right at the top, before anything else, we'll call pull sensors. And finally, a few more little error corrections before we do any testing. In handle head bump slide, this needs to be if we are not touching a wall. In land check, this needs to be reading from the struct now, since that one is no longer a frame behind. In initiate dash down here, we need to again be grabbing these from the struct. The only place we should not be using the struct versions are angle comparisons we do in our movement controller in our resolve movement functions. In velocity reset, this should be our struct version as well. And in jump checks, same with the block before the double jump. And back in movement controller, in ground probes, both of these is wall slidable checks need an exclamation mark in front of them, and we want to make sure that the angle is not wall slidable. And inside ceiling probes, we need to actually set is hitting ceiling to true. And in horizontal probes, on the right side, we copied and pasted what we did from the left, but I forgot to change the direction to +1 instead of -1. In ResolveVertical movement, I set found walkable ground to true here when we should be setting it to equal is hit walkable. Okay, and that is it for the corrections. Now, one thing that I don't love about structs is even when you're playing in debug mode, you can't see anything in the inspector. So just in case you guys are wanting to tweak things or debug stuff, I'll show you how to add a custom script so that we can actually see what's going on behind the scenes. So you can do this in a separate script if you want. I'm just going to put it right at the bottom of our movement controller script. But first we need to make sure that we have the Unity editor namespace at the top. And if you are putting it in the same script, just make sure if you're doing that, that you wrap it in an if Unity editor like this. Otherwise, you're going to get errors when you try to build your project. Now we're making a custom editor type of movement controller. And we do all of this in onInspectorGUI. And yes, we do call the base onInspectorGUI so that it draws everything else normally. We're just going to add more stuff at the bottom. So we're going to grab our controller as the target. And if we're playing, this is going to get a bit repetitive. So I'm just going to add everything in here. And then at the bottom, call the repaint method to make sure that the inspector is updated constantly. Now you can see when you hit play, all of our read-only variables show up here. Now let me show you a cool trick to properly test this out. In our pull sensors, this is a test. We're not going to keep this here. Make sure you delete it when you're done testing. But we're going to make sure it only runs if we're moving and if we're not grounded, because that's ultimately what we're trying to fix. If that condition passes, then we'll call debug.break. That will literally pause the editor. So we can turn our ground rays on and press play and run around and do a whole bunch of slopes and stuff. And if it's not pausing, then you know that we're totally safe. Now, there is a good chance that mine is performing slightly better than yours might be, and that's because I have actually changed my fixed time step to be 0.0083 instead of 0.02. 50 times per second isn't much. I wanted mine to run 120 times per second. Now, if you have a lot of complex physics in your game, then this could be an issue for performance. But if you're like me and you're mainly just relying on the physics engine for your player controller, then this should be totally fine. Most other raycast controllers end up running in update, not fixed update. And when you do it that way, you have to manually call physics2d.sync every frame to make sure that rigid body positions and collider bounds and all of that stuff is synced and kept up to date. We don't have to do that because we kept ours deterministic by putting it in fixed update. But now that that's done, you can see we're running over this ground flawlessly, and we know that because it hasn't paused. I will get the occasional pause if I'm going up and down really steep terrain like this. And if we zoom in, yeah, it's not touching anything. Though we can increase our accuracy by increasing our number of rays that we use. Every ray you add, it's a bit more expensive, but you also get more accuracy. So you're going to want to play around with it and tweak it based on how you're going to be designing levels. Anyways, that's all I got for you guys in this video. Now that our controller is stable and working really well, we're going to get to the fun stuff. We've got a bunch of improvements we're going to make. We're going to make our player rotate visually to match the slope angle. We're going to add a bunch of improvements for game feel, auto stepping for stairs or small bumps, and moving platforms with a crush mechanic. So I've got the next few episodes all mapped out. I cannot wait to put those videos out. I'm hoping it's going to be soon. So keep your eyes peeled for those. Hit subscribe so you don't miss them. Give this video a like if it helped you. And that's all I got. See you guys soon.